m cubed minus n cubed equal to 1720. We want to find m, and m and n are integers. So let's solve. M cubed minus n cubed, you can factorize it, and it is a famous identity m minus n times m squared plus mn plus n squared equal to 1720. Let's see. Here, m cubed minus n cubed. M and n, can say m is positive or not. Let's check. Oh, not necessarily, but I can tell you something. Because it is positive, so m cubed minus n cubed is positive, so m cubed is greater than n cubed, so we can conclude m is greater than n. So this part is positive, and we can conclude also this part has to be positive. So m squared plus mn plus n squared, 71720. Let's factorize this. It is a multiple of 4 and a multiple of 5. So if we divide by 20, it will be 8, 116, 126. So it will be 2, 20 is 2 times 2 times 5, and 86 is 2 times 43. So it will be 2 times 2 times 2 times 5 times 43. Now, we want to find these numbers. So if I consider different cases, uh, let's write all the possible divisors. It is 1, it is 1720, it is 2, it is this by 2, it is 8, 12, 6, and 5. Sorry, 2, 8, 8, 6, 0. And in next step, 4 is also divisors, 3 is not. 4 will be 4, 3, 0. And in next step, it is 5. If we divide 1720 by 5, it is 3, 22, 4, 24. And 6 not possible, 7 not possible, 8. If we divide by 8, it will be, let me tell you, 43 times 5. It will be this. Next case is 10. It is 172. 11, no. 12, no. 13, no. 14, no. 15, no. 16, no. 17, 18, 19, 20. You consider 20 like here. Next one is 86. 21, 2, 23, 4, not possible. 25, not possible. Okay, the next one, if you try to find, it will be 40, 40. If we count 1, 2, 3, 4, 5, 6, 7, 8, 8 times 2, 16 divisors. And if you count 3 plus 1, 1 plus 1, 1 plus 1, 2 times 2, 4 times 3, 12. 1, 2, 3, 5, 7, 8. Let's check again. 4 times 2 times 2 is 16. Okay, if you don't know how to find the number of positive divisors, you can send message to my WhatsApp number. Okay, now we have 8 cases that we should check. Let's check first case. M minus n is 1. So m is n plus 1. Now I replace here. Then m squared plus mn plus n squared equal m is n plus 1 squared plus n plus 1 times n plus n squared equal to 1720. Now we use this identity that x plus y squared equal to x squared plus 2xy plus y squared. So if we calculate, we can n plus 1 squared is n squared plus 2n plus n plus 1 times n will be n squared plus n squared equal to 1720. N squared, n squared, n squared, 3n squared plus 2n plus n 3n. 1720 will be 1719. It should be multiple of 3, and we will see it's multiple of n squared plus n. Divide by 3, it will be 5 times 3, 15, 21, 7, 3. 573, if you prime factorize, it will be 3 times 127, 91, 191. And 199, let's see, is a prime factor. And here it is n times n plus 1. So if n is 191, it will be greater. If also this one has 191, it will be greater. So the first case is impossible. Let's erase the first case. We can check also next cases like this and try to find answers. Let's check next case. M minus n is 2, so m is n plus 2. If we replace the next one here, n plus 2 squared plus n plus 2 times n plus n squared equal to 806. If we use again this identity, we have n squared plus 4n plus 4 plus n squared plus 2n for this part plus n squared equal to 806. Now n squared, n squared, n squared will be 3n squared, and 2n, 4n, 2n will be 6n. 860 minus 4 will be 856. And 556 is won't be multiple of 3 because the left hand side multiple of 3, right hand side. So second case also will be bad. Let's consider mod 3 also. We can check that. We want to say. So let's check this one. You can say something. For example, suppose m minus n is k, for example, case. M minus n is k, so m is n plus k. Let's solve it for in general. And this one will be n plus k squared plus n plus k times n plus n squared equal to 720. So it will be n squared plus 2nk plus k squared plus n squared plus kn plus n squared equal to 720. N squared, n squared, n squared, 3n squared. This plus this will be 3kn. And the right hand side is 720 minus k squared. Left hand side is multiple of 3. And sorry, it is not necessarily 720. Let me rate it. It depends on the number here. Let's consider this one c. Okay. So c minus k squared. So c minus k squared should be multiple of 3. So in the previous part, c mod 3 is what the remainder. 8 plus 6, 14, it will be 2. 2 minus this square won't be multiple. In this case, 430 minus 4 squared, 6. The remainder when divided by 3 here is 1. The remainder when divided by 3, 16 is 1. So it will be multiple of 3. We can't reject that. Let's check this one. 3, 4, 4. Let's see, we can reject which cases. So, well, I can reject all these things, and I've reached that n squared plus kn equal c minus k squared over 3. And for this one, let's check. C is 344 minus k squared. Minus 5 squared will be 1. It should be multiple of 3. The constant remainder when divided by 3. The remainder of this number when divided by 3 is 2. Sum of the digits. 25 is 1. 7 for 11, it's not possible. It is not multiple of 3. So we can reject it by considering mod 3 or remainder when divided by 3. It will be bad. Okay. This one will be bad. This one. 215 minus k squared minus 64. The remainder of this number is 1 when divided by 3. The remainder of this number 2 plus 5, 7. 7 plus 1, 8. It will be 2. Again, this is bad because of considering the remainder when divided by 3. Let's check this one. 172 minus 10 squared, which is minus 100. Mod 3, it is 1. Mod 3, it is 1. So we can't reject this case. Let's check next one. 86 minus 20 squared. And it will be what? The remainder here is 1 when divided by 3 here, 14. It is 2. Again, it is bad. And the last one, look, because this number, if you raise the power of 2, it is 1, the remainder. So we should check this number. 43 is also 1. And now, let me tell you something. Maybe someone asks that also we should consider this large number for here. Yes, we should check. In the next page, we will check. Now, let's see this case. N squared plus kn plus 4n equal to c 430 minus k squared minus 16 over 3. It will be 414 over 3, which will be 1, 3, 24, 138. So n times n plus 4 will be 138. It is 2 times 69, or you can say 2 times 3 times 23. Now, let me find a good way. For example, 2 times 3, 5 cannot be this. 23. Any of them that is multiple of 3 concludes that the number will be greater than 138. It's not possible. This one, n squared plus kn. K here is 10 plus 10n equal 172 minus k squared minus 100 all over what? All over 3. It will be 72 over 3. It will be 24. N times n plus 10 is 24. 24, we can say 2 times 12. The only answer for this is n2. So let's check this. N is 2 and m is n plus 10. So n is 2, m is 12. And we can check that 12 cubed is minus 2 cubed. 12 cubed is 1728 minus 8. It will be okay. So we found the first answer. In this answer, m is what? M is 100. M is 12. Let's check this case. N squared plus kn, which k is 40. 40n equal c, which is this, minus 40 squared. This one will be 43 minus 40 squared. It will be a negative number, but let's see, over 3. Now, we can write it is 43 minus 4 times 4 is 16, this over 3. Let's erase here the things that we don't need. This minus this, we can say negative 10 minus 3, 7. 9 minus 4, 5. And 5 and 1 all over 3, which will be negative 5, 1, 9. So negative 519. Now let's check. N times n plus 40. Let's write it. Equal to. Okay. Let's write n times n plus 40 equal to negative 519. Negative 519 is negative 3 times 173. And 173 is prime number. If n is multiple of that, we won't reach negative 3. It's not possible. Okay? Now, we consider these cases, but reverse of them. Let me write. Let me erase this part that we've not reached. Okay. So, m minus n times m squared plus mn plus n squared equals 1720. And if you want to check the cases, 172 and 172 one, the first case, we switch. 862, 862, 434, 434, 3445, 3445, 215, 8, 172, 10, 86, 20, and the last one is 43, 40. Okay, exactly like previous case. Say, but here, it is C, it is K. And we know by the formula we've said n squared plus kn, n squared plus kn equal to what from this? C minus k squared over 3. You can reject many of them by considering this, that it should be multiple of 3. Let me tell you, you can reject which of them. Because k squared here, they are not multiple of 3. Always the remainder when divided by 3 is 1. So this one also has to be 1. So you can reject 2 like previous one. That you rejected. 2 is bad, 5 is bad, 8 is bad, 10, no, 20 we can reject. So you need to only check one case, two case, three case, four case. Try to take these four cases as homework and you found any answer, comment your answer right below this video. If you have questions, send message to my WhatsApp number. Please don't forget to subscribe, turn on notification, and like the video. Thanks. See you next time. Bye bye.